Okay, so we just read the chapter 15 that talked about what things do when they're unstable. So when we have these unstable nuclei, atoms are going to emit radiation. And there's two types of radioactive decay that we want to understand here. And we want to write down some decay equations. So the first involves alpha decay. So alpha decay is a helium nucleus. This is an alpha particle with 2 protons and 2 neutrons. And again, 2 plus 2 is 4. So this is something you will want to remember, that this right here is the alpha particle. So a decay equation always starts with a parent isotope. So on the left-hand side, we write the parent isotope. So let's consider when uranium-238 undergoes alpha decay. So we would also know that uranium is always element 92, so if we didn't have that 92 there, we could still fill it in. So first off, let's get the He4/2 here. This is our alpha particle. Now what is going to be the daughter isotope? So this is always called the daughter isotope, the thing that comes out, or the thing that is a result. I don't know why there's not sun isotopes, but if you have a problem with that, you just need to deal with it. Are we done dealing with it? Okay. So now how do we figure out what the daughter isotope will be here? We have to bring back that conservation of matter concept. Just that whatever we have here total on the left has to be what we have total here on the right. So if we have an atomic mass of 4 here, 4 plus 238, or 234, sorry, equals 238. 2 plus 90 equals 92. And then if we're trying to figure out, well, what do I have here then? You just have to look back at your periodic table and know that element 90 is thorium. Let's do another example together. What about radium-226? What about when that undergoes alpha decay? So we are going to remember that alpha decay involves this alpha particle He4/2, 2 protons and 2 neutrons. 4 plus 222 equals 226, and 2 plus 86 equals 88. What's element 86? Look on your periodic table, and we have radon here. Rn. Okay, I want you to try this next example with your partner in the next 30 seconds. Just spin this around like a clock, maybe, while you're doing that. Okay, so what do we put here? Let's start out with that alpha particle, He4/2. Technically, if you put that second, it wouldn't matter. And then 4 plus what is 218? 214. And then 2 plus 82 is 84. And then how do we know what element polonium turns into? We look on our periodic table, we find element 82, and it's lead. So this is how we would go through alpha decay. Okay, now what about the other main type of decay, beta decay? Now, beta decay occurs when a neutron turns into a proton and an electron. The proton stays in the nucleus and the electron shoots off. So the beta particle is this electron with a mass of 0 basically and a charge of -1. So for a beta particle, we're always going to draw this, and that's something you want to remember. Now looking at this, what does thorium-234 turn into when it undergoes beta decay? So let's start out by getting that beta particle, E0/-1, because again it is basically just an electron. Let's think about conservation of matter again. 0 plus 234 equals 234. Now here's where it gets a tiny bit tricky. -1 plus what equals 90? Well, we have to add 1 here. So 91 plus -1 equals 90. So the atomic number actually goes up here. And then what's element 91? You look on your periodic table, proactinium, Pa. So thorium's the parent isotope, proactinium is the daughter isotope. What about for lead-210 when it undergoes beta decay? Now I'm just going to draw the beta particle second here just to illustrate that it doesn't matter where it goes. So we get the E0 over -1. That's always what a beta particle will look like. 210 plus 0 equals 210. 82 plus 82 equals 83 plus -1. And then 83 on the periodic table. This turns into bismuth. So lead 210 turns into bismuth 210 when it undergoes beta decay. Now let's try this one again in the next 30 seconds. Draw a little picture here of a bird. He's riding that skateboard. Maybe more of a penguin, I guess. Okay, we ready? So what's that beta particle again? E0 over -1. What does bismuth 214 turn into when it undergoes beta decay? Well, 214 plus 0 equals 214. And then 84 plus 84 plus -1 equals 83. And element 84 is polonium, PO. Okay, now what if we kind of did the opposite down here, and I kind of want to jump to this example. How could we figure out what the parent isotope was? Just add them up now. 4 plus 206 equals 210. 2 plus 82 equals 84. And then again, element 84 is polonium. What if I gave you this example right here? 122 turns into 122. That means this must be a 0. 53 turns into 54. This must be a -1. That means we could predict that this is a beta decay radiation. And then lastly below, thorium-230, 4 over 2. This again is the alpha. So we have 226. And then 88 plus 2 equals 90. And then element 88 is radium. So here's some decay equations that we want to be able to do moving forward.